Good morning. Good. Okay, never mind. All right. Okay, the chart below lists the sine and cosine of 45 and 30. Find sine 15 without a calculator. There's several ways of doing this. Now, I taught you guys all these ways over the time. So we could do it using addition or subtraction, or we could use like half angle theorem and stuff like that. Okay, but we're going to do addition and subtraction here. So addition and subtraction is going to be the easiest way of doing it. So just using these numbers right here, I'm going to use a subtraction, right? If I want to find 15, I'm going to do a subtraction. Say yes. Yes. Because 45 minus 30 gives me 15. That's what I'm looking for, right? So it would be, forgot to hit the thing. Here we go. All right. Sine 15. So sine 15 degrees is equal to, let me see, sine of, so 45 minus 30. Now, we've got to go to the reference sheet from here. So the reference sheet, since this is a subtraction, and I'm starting off with the sign, here they go, right here. Okay, so now for this one right here, so sine of s minus t. So for this, it's going to be sine cosine, so sine s cosine s minus cosine s sine s. So I'm going to go from here. So sine, cosine, cosine, sine. What number are we on? 16. There you go. So it's going to be sine 45 cosine 30 minus sine 30 cosine 45. I think the reference sheet actually went cosine then sine, but it's a multiplication, it's fine. I think if I recall when we were doing it in the notes, it also always went sine cosine, then sine cosine. So if it's 45 here, it's 30 here, 30 here, 45 there. Okay, there's a pattern to it. All right, so now I have the values over here on the left. I have those values there. So I'm going to say, so sine 45, so this is going to be rad 2 over 2 times cosine 30, which was rad 3 over 2, minus sine 30 is 1/2. Cosine 45 is going to be rad 2 over 2. Do my multiplication, so over here I come up with what? Rad 6, right? Rad 6 over 4. So rad 6 over 4 minus rad 2 over 4. And common denominator is 4, right? Yeah. So it's going to be rad 6 minus rad 2 all over 4. So my answer is C here. Are we okay? Question before I move on? All right, let sine s equals 2 over 3. Sine t is negative 1 over 3 with sine t in quadrant 4. Use the above information to evaluate 17 and 18. So now we're going to have to do a couple things here. So now first, I know sine. What does sine represent? Okay, so sine is y over r in this case. So let's take a look at, so for s, so my y value is 2, my x value is, I don't know, but my r value is 3. For my t, sine again is y over r, so y is negative 1, x is, I don't know, r is 3. So we're going to have to go through and actually figure out this. How am I going to find my missing value from here? Yeah, Pythagorean theorem, right? So Pythagorean theorem, it's always x squared plus y squared is equal to r squared. So it's going to be x squared plus 2 squared equals 3 squared. So it's 9 minus 4 is 5. X equals plus or minus square root of 5. Okay? Now, from here, I know that S is in quadrant 2. S is in quadrant 2. What do we know about quadrant 2? Negative. What is negative? X. The x value is negative in quadrant 2. So I know that this has to be a negative rad 5. Now, for t is in quadrant 4. So let's do the same thing again for t. So it's going to be x squared plus negative 1 squared equals 3 squared. So I'm going to get x is going to equal so 9 minus 1, right? 9 minus 1. So that's going to be, there we go. So plus or minus radical 8. So in quadrant 4, what do we know about the x value in quadrant 4? Positive. Quadrant 4, think about quadrant 4. It is going to be positive. So this is going to be a positive rad 8 there. Okay, so now for this one right here, I have to go back to the formula for the addition and subtraction. So I know you guys are looking at the reference sheet for me right now, so I know it's going to be, it's cosine S cosine T plus sine S sine T, right? Yes? There we go. Yes? So I'm hoping you're looking at the reference sheet so when you take the test, you can see where it's at, know where to find it. Okay, so cosine S is going to be negative rad 5 over 3. Cosine T is rad 8 over 3. And plus sine of S is going to be 2 over 3. Sine of T, negative 1 over 3. So I'm going to come up with a negative rad 40 over 9 plus, ooh, that's a negative 2 over 9. I'm going to have to do some factoring here. That 40, what can I factor out of the 40? 4 times 10, right? And we know square root of 4 is 2. So this will factor to a negative 2 rad 10 over 9 minus 2 over 9. So which one's my answer? B. B has to be my answer here. So I know you guys wrote down my S's and T's right here because I have to use this again for question 18. All right, what is simplification of the expression sine of 2s? Now, we have to go to the reference sheet. This is a different place in the reference sheet. It's a double angle. So here's my double angles. So right there in the top, sine of 2s. So it's going to be this double angle, so it's going to be 2 sine x cosine x. So it's 2 sine x cosine x. There we go. So, wrote out the formula, so now I need just my S values for this. Just my S values. So you guys can help me. So it's going to be 2. Now, what was the sign of S? 2 over 3. What was cosine S? Like that? So I'm hoping people aren't playing with their phone the whole time and writing all this down. So from here, let's see. So go ahead and do our math, and we're going to come up with a negative out of it. So it's a negative 4 rad 5 over 9. The answer is C. Questions, you guys? Nope. Use identities to find the exact value of cosine 7 pi over 12. Now, 7 pi over 12, people don't like that. You don't like radian. I really think that this year you guys just really don't like radian. So what would you do if it's in radian? Put it in degrees. Please do that right now. So, 7 pi over 12 times, very good. So pi, I know, right? Always. So pi's cancel. So you're going to get something. 105?
Yeah.
Very good, 105. So now we're actually trying to find the exact value of cosine 105. So we're going to use addition or subtraction. I'll let you choose. To get 105, what are you going to do? What two numbers can you put together to get 105?
Oh.
Adding. So what am I adding together to get 105? Just stuff from my unit circle. That's what I need. 45 and, there we go, 45 and 60. So cosine of 105 is equal to cosine of 45 plus 60. Now, at this point right here, I identified what I have. This is an addition, so I have to go to my reference sheet and actually find it. So, the formula for this one, it's going to be cosine cosine minus sine sine, right? Yes? Okay, so I know you guys are looking at that. So this is going to be cosine 45, cosine 60 minus sine 45, sine of 60. Given the unit circle, cosine 45, rad 2 over 2. Cosine 60 is 1/2. Minus sine 45, rad 2 over 2. Sine 60 is rad 3 over 2. Okay, let you guys get caught up. All right, go ahead, multiply it out. Rad 2 over 4 minus there we go. So combined common denominator, rad 2 minus rad 6 all over 4. My answer here is D. Wow, I thought I fixed that one. All right, use identities to write each expression as a single function of x. So we already have everything there. So now this is working backwards from what we were doing. So if it goes sine, cosine, minus sine, what identity was that? Look at your reference sheet. You have to match it exactly. So it's sine, cosine, and then minus. Is it a sine or a cosine function? It's a sine function. So this is a sine function. And is it a plus or minus?
Minus.
So it is going to be a minus. So this is going to be 40 minus 60. Or 160, right? There we go. 160. So it's going to be sine of 40 minus 160 is?
Negative 120.
Negative 120. I don't like negatives. What would it do if I don't like a negative? Coterminal. Add 360, right? Add 360. So add 360 to that, we get 240. So we're looking for the sine of 240 degrees. So that's going to give me somewhere in quadrant 3. It is a negative, right, 3/2?
Yes.
Okay. Okay, so let's take a look at the next one. Perform indicated operation, simplify. All right. Man, this one's too easy. Anyway, watch. Do they have the common denominator?
Yes.
What's the common denominator?
X over R.
This is just cosine, right? Listen, it's so easy, I don't even have to translate it. Okay? So it's going to be sine squared theta plus cosine squared theta over the common denominator of cosine theta. What's this on top?
1 over cosine.
Yeah, this is 1, right? Sine squared plus cosine squared is always going to give me 1, right? So this is 1 over cosine theta. What's 1 over cosine?
Secant.
Secant. So it's going to be secant theta. So if we had to do like the x, y's, and r's, I would actually do that one. But this one right here, since sine squared plus cosine squared will always give me 1, that eliminates all the work. I really don't have to do much. I just have to know that sine squared plus cosine squared is always going to give me 1. All right. 22. Do the stop. There we go. All right, there's 22. The area of the triangle given the measurements. All right. I have angle A, I have little b, and I have little c. Area of a triangle. I had big A, right? I have big A. Do I have little b, little c?
Yes.
There it is right here. I have everything I need, right? So it's going to be area is equal to 1/2 BC sine A. So area is half little b, 13.6, little c, 10.1, and sine of 42.5 degrees. Now, this is one we're putting in the calculator. What do I have to double check?
That it's in degrees.
It's got to be in degrees. Very good. This has to be in degrees because it gives me degrees. So, please calculate. You just say B? Easy? Okay, so that means we're gonna have to leave. Wait, can I do one more? I might be able to do one more. Oh, no, I have 4. Okay, which expression can be used to find the height of the oblique triangle? Okay, so given the triangle, I can look at this from either A or B, or I'm sorry, A or C. So from here or here, it doesn't matter. So if I'm looking for H, so from this side right here, this would be the
What?
just look at it right there. So from here, this side is the little a, which is going to be just right angled, like SOHCAHTOA.
What?
That would be the opposite, right? This one over here is
Hypotenuse.
hypotenuse, and this is my
Adjacent.
adjacent here, okay? So, to be able to solve for this, I could actually do this using sine, cosine, or tangent. So, I'm going to look at it. So, I'm going to say, let's go with sine. So, I could say that sine of A is equal to opposite, which is my H value, over, I'm changing this color. This is a horrible color. H over, I think that was C over there, little c, yeah. So multiply, so it'd be C times, because I multiply both sides by C, sine of A is equal to H. C times sine of A is equal to H. Yeah, it's there. There's a couple different possibilities. You just have to go through and work out which one that they're giving you the opportunity for. All right, I'll pick up the rest of this tomorrow.